Okay, so in this video, we'll be discussing Pure Mathematics 3 for May-June 2023, paper 3-2. Okay, so let's have a look for question number 1. We are having the inequality with both sides with modulus. So you can see that both sides I'm having modulus for this inequality. Okay, when I'm having the start of the question with both side modulus, the easiest way I find out is to square both sides. So when I try to square both sides, right, my modulus will become disappear. So I'm having 5x minus 3 square, then smaller than 2 square, then with a bracket 3x minus 7 square. Right, so when I square both sides, I try to expand them. So I'm having 25x square minus 30x plus 9. Then the 2 here will be 4, become 4. 2 squared is a 4, right? So 9x squared minus 42x and then plus 49. Okay, then further simplify it. For the right hand side, I will have 36x squared, then minus 168x, then plus 196. Okay, then I'll try to move everything to one side, and thus I get the quadratic inequality. Okay, so to solve the quadratic inequality, there are many ways that you can solve it. Right, so basically what I need to do is that I have to factorize them. So to factorize them, maybe we need to try and error a little bit. Okay, so to try and factorize it, or maybe you can use the calculator to help you to factorize them. So I'm having two critical value here. Our critical value will be x equals to 11 and also x equals to 17 over 11, right? So these are the two critical value that I have. Okay, then to decide the answer for inequality, you can use many other way to solve it also lah. Right, so for me, I'm using the number line. I'm having 17, 11 is bigger number, so 11 is here. 17 over 11 is smaller, so it should be somewhere here. So draw the arrow, the bracket, 11 minus 17, right? Positive means that I have this line. Then for the bracket x minus 11, to make it positive, I'm having this line, right? Then I'm having a plus, minus, then plus here. Sorry, so this one should be minus. The part without the line should be negative, right? Then positive, negative, positive, positive. Okay, so since I'm looking for greater than 0 for my quadratic inequality, therefore the answer that I should accept should be from here and also this highlighted part. So when I write out the final answer, it should be x smaller than 17 over 11 and also x greater than 11. Alright, so this is what we have, okay, for solving this inequality with both side modulus. Alright, so we are now at question number 2. For question number 2, we are having the equation with ln, something with ln, okay, and then they want us to give the answer in exact form. So highlight the word exact form. Our answer should be in maybe a third form or maybe in ln or in terms of e. Okay, it shouldn't be any that long decimal number lah. So when you see this one, maybe you need to take note on this. Okay, so to solve this particular equation, right, both sides I also have some terms with ln. Okay, and then if I want to cancel off the ln, right, I have to make sure that my equation rephrase become ln something equals to ln something. That only we can cancel off the ln straight away. Right, so now that means I need to try and combine my right hand side, become a single ln. Okay, so left hand side I just keep it as what they show. And then for the right hand side, I'm having ln x squared minus ln 2. Okay, and then left hand side, I still keep it as usual. Then for the right hand side here, ln x squared minus ln 2, you can use the result of ln a minus ln b can be combined or written as ln a divided by b, right? So basically, this is what I'm going to use here for this step. So I'm having ln x squared divided by 2. And now you can see that both sides we only have one ln each. Therefore, we can cancel off the ln and left only with this one, x squared minus 3 equals to x squared over 2. So I'm having 4 squared minus 6 equals to x squared. Then 3x squared equals to 6. Okay, then further simplify it, I will have x equals to plus minus square root 2. Okay, so before we decide the final answer, we need to double check again. For x, right, I'm having two values here where one value is square root 2, another value is negative square root 2. So we need to figure out and see, do we accept both answers or we only accept one of the answers? Okay, so what we are going to do now is we have to try and substitute and see that. If let's say I'm taking x equals to square root 2, right? Substitute back into the original equation, is there any problem or not? There should be no problem. But if I substitute negative square root 2 inside my original equation, there's a problem here where we will get a math error, because when we are having ln negative square root 2, it will actually a math error, because ln x, the x is only defined for positive value, x greater than 0. Therefore, we shouldn't accept both answers for this case. We should only accept the answer square root 2. So our answer should be x equals to square root 2. And then we ignore the value of x equals to negative square root 2. Right, so that means we only accept one answer for this question. Okay, so question number 3. They want us to sketch the locus of the point representing complex number z satisfying this inequality, this equation on the Argand diagram. Alright, so before we can sketch the Argand diagram, right, we need to rephrase this equation become z minus a complex number. So if I want to rephrase it now, I'm having z minus a complex number modulus, and it is equals to 2. And then by right, I should have negative 3, so that minus negative 3, I get a positive 3 here, right? And then for this one, I'm having plus 2i. When I have one side with modulus function, the other side is a number, basically this kind of locus will be a circle. And the center is actually this complex number, where center is negative 3 and 2. Alright, then what's the value of 2 here? The 2 here basically means the radius. So the radius is equals to 2. Okay, because for the whole inequality here, it is actually means that the point z, the distance, modulus means the distance, right? So the distance of point z from the point, okay, is equals to 2. Therefore, when you're having all the z that is 2 unit away from the center, right, from the complex number, we actually form a circle, the locus with a circle. Okay, all right, so since we already know the center and also the radius, so we can try to plot it. You can try to use a clear ratio for yourself. So I'm having 1, 2, 3, 4, 5. This is negative 3. Okay, and then for this one also the same. So I'm having 1, 2, 3, 4, 5. Okay, so my center is at negative 3 and 2, right? So this is my center. It will pass through the point negative 1 and 2, negative 5 and 2, then negative 3, 0, and also negative 3 and 4. So if you want to make it nicer, right, you can use a compass or whatsoever, okay? Whatever tools are to help you to sketch a nice circle. Okay, so if I want to draw a nice circle, hopefully I can draw a nice one. So it should be something like this. My circle is not nice enough. Okay, but generally try to draw it as nice as possible. And then from here, you can show that there's a 2 unit for the radius. Okay, then we are having imaginary axis for the y and also the real axis for the x. Okay, so this is what we have for first part, part A. It should be a circle. So this circle is my locus z. Alright. Okay, then now let's proceed further to part B. So for part B, they want us to find the least value of modulus z for the points on this locus, giving your answer in exact form. So highlight the keyword exact form again. Okay, they are asking for the smallest value of modulus z. So what's the meaning for this modulus z here? So you can see that modulus z, I can rewrite become z minus 0 plus 0i, which means that we are going to find out the shortest distance, okay, between the z and also 0, 0, between z and 0, 0. Okay, and z is the locus that we draw just now, right? So that means if you refer back to our diagram just now, z can be anywhere on the circle. Alright, so we are looking for the shortest distance between the z and also with this point 0, 0 here. Okay, so usually for this kind of question, right, to find the shortest distance of z, it will be actually go through the center of the circle. Alright, and then the shortest distance will be this particular part here. That means all my z is at this point, and then this is my shortest distance. Okay, the thicker line here is the shortest distance that I want to calculate. This is the shortest distance between the z and also 0, 0. So why I know that this is the shortest distance? Because when we are having the point 0, 0, that pass through until the end of the circle, okay, that cross over the diameter, it will be the longest distance, right? Okay, so when you have anything that pass through the diameter of the circle, it should be the longest distance. Therefore, when they want us to get the shortest distance, it will be also the same line, but we don't include the diameter. So this particular line here will be the shortest distance. Okay, so how can I get the shorter distance here? Alright, so by using my diagram here, I will show you the solution for part number 2. Part B, right? Sorry, it shouldn't be part number 2, it should be part B. Okay, to get the distance here, basically what I want is, I want to take this distance from the point -3, 2 until 0, 0. So I take the distance between -3, 2 and 0, 0. After that, I minus the radius, which is a 2. Then I will get the shortest distance for z. Okay, so the least value of z will be equals to, what is the distance between -3, 0, -3, 2 and also the 0, 0? So it should be -3 x minus x square plus y minus y square. Okay, so this is the long distance here. Then I want to minus the radius, which is a 2, right? So minus the radius 2. By right, you should get the answer square root 13 minus 2. And I want to keep my answer in the exact form, right? So this will be my final answer. Okay, so usually for this kind of question, you might need to refer to your diagram a little bit. Let your diagram help you, okay, to decide how to determine or how to get the shortest distance or the longest distance. Okay, so now we come to question number 4. They want us to solve this particular equation. And then before I can solve it, maybe we need to analyze a little bit. What is the next step, or what is the formula that we can use to solve this equation? Okay, if I try to observe this question, right, I realize that I'm having two types of different angle. One is x, another one is half x. So what is the relationship between these two angles here? They are, the half x is half of the original x. Okay, so there or maybe we can say that x is the double angle for half x. Okay, so to solve this question, very likely we can actually use the double angle formula. Okay, so the original double angle formula will be cos 2x can be written as 2 cos square x minus 1. Okay, this is the original equation that we have for double angle formula. And then to apply in this particular question here, we can actually modify the question and become cos x. If I have 2x, to change it become cos x, right? The pattern of the formula is still the same, but for the x here, we need to also divide it by 2. So I'm having half x, then minus 1. So basically, I want to use this one. After modify the double angle formula, I want to apply this equation into my solution here so that I can continue to rephrase my answer. Alright, so let's start. So I'm having 2 cos x, I want to use this one. 2 cos square half x minus 1. So I will substitute inside 2 cos square half x, then minus 1. Okay, then minus cos half x equals to 1. Okay, then simplify it further. And I bring also the 1 over become -1. Rephrase the equation further again. Then you will realize that actually we get a quadratic form equation in terms of cos half x. Okay, so this is a quadratic equation. I hope that you can see the pattern now. Quadratic equation. So now how are we going to solve the quadratic equation? You have to either factorize it or maybe you have to use the quadratic formula, right? Okay, if I observe this question, basically we can see that we able to factorize it nicely. So I'm having a 3 here, this is the 1. Then to have a negative cos half x, I need to have minus 4. Then plus 3 cos half x. Okay, so from here, if I try to simplify it further, I'm having cos half x equals to negative 3 over 4. Another value will be cos half x, then equals to 1. Okay, then let's proceed further. And now I want to get the basic angle for this particular question. So the basic angle will be cos inverse, ignore the negative sign, and I will have 3 over 4, cos inverse 3 over 4. Okay, then in terms of radian, right, it should be something like 2.41. Oh, sorry, not 2.41. I didn't get the basic angle out, but I just write it as cos inverse 3 over 4. Okay, but later you need to calculate in radian, in the radian unit, in the unit of radian. Okay, this is my basic angle. Then now I want to go through the quadrant and find the value of half x. Okay, so now we need to be a little bit more careful to go through with the quadrant and find out the value, right? So I'm having everything is positive in first quadrant, sine positive, cos positive, tangent positive, then cos positive, tangent and then cos. Okay, and then for first quadrant, right, to get the answer, it is pi, which is the basic angle. Then for this one, second quadrant will be pi minus theta, which is the theta is the basic angle. Then the third quadrant is pi plus theta. Then the fourth quadrant is 2 pi minus theta. So when you want to go through the quadrant, right, first of all, you must find out the basic angle first, where the basic angle is the theta. Okay, then now, I'm looking for half x here. I'm looking for half x here. So how many quadrants should I go through? Okay, if I want to go through all the quadrants, I should refer back to this one. The request in the question here, x is between 0 until 2 pi. If I'm looking for the answer for half x, it should be from 0 until pi only. So that means I should go through with the first two quadrants for the value of half x. Okay, so for the first quadrant, what am I looking for? For the answer, I'm looking for cos negative value. So in the first quadrant, is it cos negative? It is not, right? So I don't want the answer from first quadrant. Then I proceed to the second quadrant. So for the second quadrant, cos is negative. That means I want to accept the answer from this quadrant here. How to get the answer for this quadrant? You have to take pi minus the basic angle. So you take pi minus cos inverse 3 over 4. If you take pi minus cos inverse 3 over 4, you'll get a very long value. So I will keep it as long as possible before I get the final answer. Okay, so by right, you should get this answer here. And then should I proceed to the third quadrant or not to check whether should I accept the answer from third quadrant? Basically, I no need to continue my step for the third quadrant anymore. It is because of half x, right? The range for half x is only from 0 until pi. So pi is until second quadrant only. That means you don't need to proceed further for the third and fourth quadrant anymore. Alright, so that means for half x here, I will stop here. And then to get the value of x, you need to multiply the answer with a 2. And this is my answer already, right? So I will cut it short to 3 significant figure where I should have x equals to 4.84. Correct to 3 significant figure. Okay, so this is the first part of my equation here. And now continue to the second part of the equation. So for the second part of the equation, I'm having cos half x equals to 1. Again, to get the value for half x, it is bounded within 0 until pi. Okay, so how can I get the value for cos half x equals to 1? So the 1 here is a special value. To get the value of x from all this special value here, you actually need to refer to the graph of cos x. So I'm having the original cos x graph like this. Okay, then this is 2 pi. Then the 1 here, this is a 0. This is negative 1, where the value of x is a pi. So they are asking for cos half x equals to 1. and your value of half x should be between 0 until pi. According to the diagram here, I have only one value that give you the 1. Cos half x equals to 1. So that means your half x should be equals to 0 and your x should be equals to 0. Okay, so the next value that you get the 1 is 2 pi for the x, which is already out of the range for half x. Therefore, I didn't accept this answer 2 pi in our calculation. Okay, so you can see that from here I have two values of x that fulfill the equation. Therefore, please rewrite again. X, we are taking two values here. One is 0, another one is 4.84, correct to 3 significant figure. Right, so please take note about this also, where x equals to 0 is actually one of the answer, yeah. Because some students say that, oh, x equals to 0, then they didn't accept it as an answer. But basically, x equals to 0 is also one of the solution. So you shouldn't ignore it. Okay, so for this question, basically, we are having two answer, two solutions for the x, where x equals to 0 and also x equals to 4.84. Okay, so now we come to question number 5. We are having a complex number 2 plus yi, which is denoted by a. And then y is a real number. Then y is smaller than 0. Okay, then it is given that the function fa is equals to a power 3 minus a squared minus 2a. They want us to find a simplified expression for fa in terms of y. Okay, so to find out fa in terms of y, basically we have to substitute lah. Okay, a by using the 2 plus yi, so that I will have a function in terms of y later. Okay, alright, so I'm having fa, which is equals to a power 3. So a power 3 means that I'm having 2 plus yi for 3 times, right? Power 3 means they multiply each other together for 3 times. Then minus a squared, I'm having 2 plus yi multiplied with 2 plus yi, and also minus 2a. So 2 plus yi again. Okay, so now I need to slowly expand them. Okay, so 2 multiplied with 2, you'll get a 4. Then same thing happen, 2 multiplied with yi, I'm having 2yi. Okay, then for the center one, yi multiplied with 2, I'm also having 2yi. And then if you multiply this one, y multiplied with yi multiplied with yi, you will have y square I square. Okay, and then the same thing happen for these two brackets. After you expand, you should have something very similar to what we have here. Okay, so I'm having 4 plus 4yi. Okay, then plus y square I square. Then minus 4 minus 2yi. Okay, then now, before you can continue to expand the other bracket, you need to try to simplify the I with power first. Okay, so let's have a look here. I'm having I square here. So please take note that I square is actually equals to value of -1. Because I means square root -1 multiplied with square root -1. Therefore, you're having -1. Okay, so I square will be equals to -1. So please substitute into our calculation here before we can continue to expand it. Right. Okay, so if I continue to simplify, I'm having 4 plus 4y, then minus y squared, because the I square is the I square is -1, right? Okay, then after that, only I put in 2 plus yi. Same thing happen for this one, I'm having -4 minus y squared, and then plus 4yi. Minus 4 minus 2yi. Okay, then next we need to further expand it. Okay, so we have to expand these two brackets here now. Alright, okay, so expand slowly. I'm having 4 times 2. First term multiply the first term, I get 8. First term multiply the second term, I'm having 4yi. Then second term here, multiply with the 2, I'm having 8yi. 4yi multiply with yi, you are having plus 4y square I square. Then the last term here, I'm having -2y square. Then -y power 3i. Okay, so multiply the negative inside the bracket, I'm having -4 plus y square minus 4yi, then minus 4 minus 2yi. Okay, so it looks like a very long expression here, so we slowly simplify them. Okay, so let's simplify the yi first. Okay, the term with yi. So if I have a look for this one, I'm having 4yi plus 8yi, which is 12. So 12yi minus 4 become 8, then minus 2 become 6, right? So when I simplify, I'm having 6yi. Okay, then next one, we can try to maybe simplify the constant, okay, with number. Okay, so let's have a look for the constant here. I think I'm having 8, which is a constant. And after that, what else do I have? I have minus 4. 8 minus 4, you get a 4. Then minus 4 again. Therefore, you get a 0. So there's no constant term after you simplify them. Okay, and then after that, maybe you can have a look for y square. I'm having 4y square I square, right? Since I square is negative 1, so I'm having negative 4y square. So negative 4y square minus 2y square, I'm having negative 6y square. So negative 6y square plus 1y square, you're having 5y square, right? So you can, after you simplify, you're having, negative 6 plus 1, you're having negative 5. So you're having negative 5y square. Okay, so what is the remaining term that we haven't simplified yet? So you can see that we still have one more, which is this one. Okay, so you just copy it down in your solution. So I'm having negative 3y power 3i. Okay, so after we expand everything, so now we want to rephrase it into the pattern of a complex number. Okay, so complex number is having x plus yi, right? Real part in the beginning, at the beginning, and then the imaginary part at the end. So my real part is actually negative 5y squared. Then for the imaginary part, I'm having 6y minus y power 3i. So this is actually what we get for the function fa in terms of y. After I substitute the a into the equation, into the expression, and then expand and simplify that. Okay, so this is what we have for part A, question number 5. So let's have a look for part B. Okay, so for part B, they are telling us that the real part of fa is equals to negative 20, and now they want us to find the argument of a. Okay, so let's talk about the real part of fa first. This is my fa. So where's the real part of fa? The real part means that the part without any complex number I, right? Okay, so this is the real part. Okay, so negative 5y squared is equals to negative 20. So when I write like this. So negative 5y squared equals to negative 20. So from here, I try to get the value for y. I'm having a 4. Y equals to plus minus 2. Okay, so for this question, right, for this answer, right, should I accept both answer or should I accept only one? So you have a look in the question again. For question number 5, they actually did mention that y is a negative value, like y smaller than 0. Alright, therefore, in our solution here, we only accept y equals to negative 2. And then we ignore y equals to positive 2. So y equals to negative 2 will be the value that I have. And this is not the end yet. We need to find out the argument of a. So after we know y is equals to negative 2, right? Okay, I want to know what's my complex number a now. So again, go back to the question. Complex number a is 2 plus yi. So I'm having 2 plus yi means minus 2i. Okay, so my complex number a is 2 minus 2i. To find out the argument for a, maybe you can try to imagine where is your complex number a? A is 2 and negative 2. So this is 2, this is negative 2, and this will be your argument of a. So to get this argument of a, what I do is I will apply the formula. I will try to find the basic angle first. You can see this is the acute angle, right? So to find the acute angle, it should be tangent inverse 2 over 2. I ignore the negative sign because I want to get the acute angle itself. If I substitute in the negative, I might get the answer from different quadrant, right? So for me, usually my practice is I will try to find the acute angle first, or basic angle I will say, which is ignore the negative sign one, and I'm having 2 divided by 2. So tangent inverse 2 divided by 2, I'm having tangent inverse 1. No? And because of this argument A, right, is in the fourth quadrant, and you can see that we are measuring our argument from the positive x-axis in the clockwise direction. Therefore, my angle should be in negative. Negative angle means that we are measuring it in clockwise direction. Anti-clockwise is positive angle. So clockwise direction is negative angle. Therefore, I can put a negative in front, and therefore I will have negative pi over 4. So basically, this is how we actually find out the argument of A. Okay, so now we are at question number 6. We are having this equation, cotangent half x equals to 3x has one root in this interval, denoted by alpha. They want us to show by calculation that alpha lies between 0.5 and also 1. So to prove that alpha lies between 0.5 and 1, I will want to apply sign change method, where we try to find the sign change for the expression for this particular equation. So to get the expression, I will just try to put it like this. I will let fx, then I try to move everything to one side. So that means either you can move the 3x to this side, or maybe cotangent half x to the other side. Okay, right. So for me, I will write it out in this way, where I'm having 1 over tangent half x, which is cotangent half x, then minus the 3x. Okay, then to prove that the alpha is lying between 0.5 and 1, right? You should try to substitute in the value. Substitute 0.5 into your equation here. By using calculator, you should get 2.42. Okay, so just a reminder, because we are having the phrase, the expression in trigo, then when you want to substitute in the value, right, please ensure that you are putting your calculator in the radian mode. Alright, then only you'll get the answer correctly, which is 2.42. And next one, you substitute 1 into the equation here, into the expression here, then you will get the negative 1.17 by using the help of calculator. Right? Okay, so from here you can see that to prove that the alpha is lies between 0.5 and 1, right, we must see the sign change appear between these two values. So you can see very clearly that one is positive value, one is negative value. Therefore, you can make a simple conclusion where sign change can be seen. Between f0.5 and also f1. Okay, which also means that the alpha actually lies between 0.5 and also 1. Okay, so this is how we show by using calculation. Okay, then now let's proceed to part B. For part B, they want us to show that if a sequence of positive values given by the iterative formula, this one, converge, then it converges to alpha. So when we are having this kind of question, right, basically what we want to do is we need to prove the original equation to get the iteration formula, or the other way around. You can also do it in this way where you start from iteration formula and continue to prove until you get the original equation. Okay, so for me, I will start from original equation here. You might need to do a little bit of drafting before you can write out the complete solution here. Okay, so I'm having cotangent half x equals to 3x. I realize that there's a tangent in my solution, right, in my iteration formula. Therefore, I want to change my function, my equation in terms of tangent. So I'm having 1 over tangent half x equals to 3x. So I want to bring it up, become tangent half x equals to 1 over 3x. Okay, so I can see that the 1 over 3x is inside of the tangent inverse. Therefore, at this particular step, I will straight away take the tangent inverse, where I'm having tangent inverse, then 1 over 3x. Okay, so you can see that actually I already have this part. This part is done. Okay, after that, if I want to get a 4, right, outside the tangent, I might want to change my expression here, become something with a 4 at the bottom. Correct? So if I want to change it become the 4 at the bottom, then I will have 2x on top. So that when I simplify that, I'm getting 1 over 2x. So tangent inverse 1 over 3x. Okay, so next step, I will move the 4 over. Therefore, I'm having 2x equals to 4 tangent inverse 1 over 3x. So you can see that I'm one step closer to the iteration formula, this one. Okay, and then now, if I want to continue for the next step, right, I realize that there's something with a 3. So I need to try to link the 3, right? Or maybe our 2x here with the 3. For 2x, if I want to link it with 3, maybe I can change it to become something like this, where 3x minus x. And I will get a 2x as well, right? So if I'm having 3x minus x, then I will have 4 tangent inverse 1 over 3x. And then I move the x over. Therefore, I'm having x plus 4 tangent inverse 1 over 3x. Then again, if you try to observe the equation of iteration formula, I'm even one more step closer to the final answer. Okay, so I think until this step, it is very clearly shown that after you move the 3 over, then you will get the iteration formula that they want us to show. Okay, so for this question, you can do it in this way. That means we start from original formula, come to iterative formula. Another option is you start from iterative formula and get the original formula, where I feel that it will be easier. Okay, if you want, you can try start from the iterative formula and leads to the original formula. This is the step that I believe it will be easier for this question. Okay, or maybe some student will choose to start from original formula, prove to a center expression, and then start from this side, also go to the center expression also can. Alright, so this is how we actually solve, how we prove okay, from original to iterative or from iterative to original. Okay, then we can continue to part 3. So for part 3, part C, they are saying that, okay, by using the iterative formula to calculate alpha, correct to 2 decimal places, and then each iteration should be 4 decimal places. Okay, so I rewrite again the iterative formula. Our iterative formula is x equals to 1 over 3, and then x plus 4 tangent inverse 1 over 3x. This is my iterative formula. So to find out the final answer for alpha, I need to have an initial value first. So usually for the initial value, I will refer to the to the part A where usually they ask us to maybe to prove the alpha lies between any value. That means the part that we try to use a sign change to solve on. Okay, right. So I will use that value as reference. So in first part, they are saying that alpha lies between 0.5 and also 1. So you can use any value between 0.5 and 1 to start with. Okay, you can make it as a initial value. So for me, myself, I'm using A1 equals to 1, alpha number 1 equals to 1. The initial value as a 1, okay, to start for the calculation for the root. So to get the A2, basically the idea is you need to substitute the 1 into your iterative formula. Okay, then you get the A2. Of course, you can use the help of calculator. Okay, so but before that, you need to key in the formula into the calculator correctly. So to key in the formula, what do we have here? Okay, so we have a fraction, and then the denominator is a 3. Okay, so the denominator is a 3. Then on top, I'm having x. So for x, I'll put it as alpha x. Okay, then plus 4 tangent inverse. So I'll put tangent inverse. Okay, then 1 over 3x. So you put the bracket again, 1 over 3x. Okay, so we close bracket. right? So this is my iterative formula and you need to key in into the calculator. And before we start the calculation, right, don't forget to change our calculator from degree into radian mode. So I need to change it become shift mode. Then I need to have a 4. Yeah, so after I change it become the radian mode, then only I can start the calculation. Okay, so how to start? You press calculate in your calculator. Then you insert the first initial value. The initial value is a 1. So you key in the 1, press equal sign, and then you get this value here. We want to take the answer correct to 4 decimal places. So it will be 0.7623. So I will write it out as 0.7623. Okay, so of course I need to continue to find all the iteration before I can get the root. So to get the alpha number 3, I need to substitute the value 0.7623 into the iterative formula again. So I press calculate again on calculator, key in the value 0.7623. After that, press the equal sign, and then I'll get this value 0.8037. So our alpha number 3 is 0.8037. So you can see that these two values are not repeated yet, right? So you should continue to find out all the iteration until 2 decimal places answer are repeated. Okay, so let's continue from here. Okay, so press calculate again, key in the value 0.8037. Okay, press equal sign, I get 7921. So 0.7921. 2 decimal places answer not repeated yet from alpha 4 and alpha 3. Therefore, continue to find the next iteration. Okay, press calculate again. Key in the value 0.7921. Then press equal sign. Then you're having 0.7951. So 0.7951. Okay, alpha number 4. Alpha number 4 is 0.79. Alpha number 5, the answer is 0.80, correct, to 2 decimal places, right? So it didn't consider as repeated yet. So just continue again to get the alpha number 6. Okay, press calculate. Then key in the value 0.7951. Press equal sign. Then I'm having 0.7943. So 0.7943. Okay, so still not repeated yet. Continue again for alpha number 7. Press calculate. Key in the value 0.7943. Then press equal sign. Then this one I'm having 0.7945. So 0.7945. Okay, so if you try to observe the 2 decimal places answer for these 2 alpha, basically you realize that they are the same, which is 0.79. So after you get a repeated value for 2 decimal places, then you can straight away tell them that the root or the alpha is actually equals to 0.79, correct, to 2 decimal places. Okay, all right, so please make sure that in this calculation, right, when you list out all the iteration value here, please put it into 4 decimal places according to what they want in the question. And then the final answer root is actually up to 2 decimal places only. All right, so this is how we solve question number. Okay, so now we are at question number 7. We have an equation of a curve. And then I think it's quite obvious that this one you cannot like separate the x and y to 2 different sides. Okay, so now they want us to show that dy dx equals to this phrase, this expression. Okay, so since we cannot separate y and x clearly, right? So to find out the differentiation, we have to apply implicit differentiation. Implicit differentiation. Okay, so to apply for implicit differentiation, we we differentiate term by term, right? So let's have a look for the first term, 3x squared. When I want to differentiate 3x squared, put a power in front. 2 multiplied with 3, you get a 6, so 6x. Okay, so this one by right you should write dx, but because dx equals to 1, therefore usually we didn't write out. Okay, then after that, the second term. So for the second term is 4xy. You basically need to treat it as 2 brackets, the product of 2 different functions. Maybe the first bracket is 4x, second bracket is y. So this is actually the product of 2 functions, right? When you want to find out the differentiation for product of 2 functions, you need to apply product rule, where the concept is like you copy the first bracket, differentiate the second, then you copy the second bracket, differentiate the first. Okay, so now I copy the first bracket first, differentiate the second. Second is a y, so differentiate y, I get a 1. And because it is something related to y, right, so I put it as dy dx. Okay, then plus. Just now you copy the first bracket, differentiate the second. So now you copy the second bracket where you copy the y, and then you differentiate 4x. So differentiate 4x is you get a 4. And then differentiate 4x, right? This is something related to x, so you should put dx dx. But usually we didn't write out. Okay, because dx over dx is equals to 1. Right? So just to let you know that this part is actually the differentiation by using the product rule for the second term here. Okay, then after that for the third term, I'm having 3y squared. So differentiate 3y squared, I will have 6y. And again, because this is something related to y, therefore I have to put dy dx after the after the differentiation. 5 is a constant. After you differentiate it with a 5, you get a 0. Okay, so now the next step is I need to rephrase my answer so that I can write it dy dx in terms of x and y. Okay, so for me, I will take out the dy dx first. Then for the first term here, I'm having 4x. Then for this particular term, I'm having 6y. Then equals to the rest of the term without the dy dx, I will bring it to the other side, which is negative 6x minus 4y. Okay, so we are very close to the final answer. To get the dy dx, I bring everything over. I can factorize out negative 2 from the numerator. Then divided by, I can also factorize out the 2 from denominator. Okay, so after I simplify the 2, then basically we already get the answer that they want us to show. Okay, so this is how we prove. We are applying implicit differentiation. Okay, then now proceed to part number 2. Okay, so for part number B, they want us to find the exact coordinate of the 2 points on the curve which the tangent is parallel to y plus 2x equals to 0. Okay, so there are a few important keywords here. Highlight the keyword exact coordinates. So exact means that your final answer should be in third form. Okay, and then you have to take note that we are having two answers later because we are having 2 points on the curve. And then they are saying that tangent is parallel to this line. So tangent parallel to this line means that the gradient of tangent, which is dy dx, will be equals to the equation, will be equals to the gradient of this particular line. Okay, so since I'm having y equals to y plus 2x equals to 0, and I get y equals to negative 2x, right? Okay, so the gradient is actually negative 2. Since the tangent is parallel to this line, therefore the gradient of tangent, which is dy dx, also equals to negative 2. Okay, so substitute dy dx into this equation. So this is the dy dx that we get from first part, yeah. Okay, so equals to negative 2. So now I want to start to rephrase my equation to solve them. I'm having 2 and then 2x plus 3y. Okay, then 3x plus 2y equals to 4x plus 6y. Okay, then if I slowly simplify them again, I'm having x equals to negative 4y. And then I can't do anything anymore with this equation, right? So I will just label it as equation number 1 first. And then to solve the equation and get the value for x and y, I will need to substitute them, okay, into the original equation, because this is actually to show the coordinate of the curve of the point on the curve, right? So you have to substitute x equals to negative 4y into the original equation. So our original equation is this one, this long one, okay, 3x squared plus 4xy plus 3y squared equals to 5. Substitute the value just now, the x equals to negative 4y, into this equation. Okay, so I'm going to do it now. Okay, substitute 1 into the equation. Okay, so make sure you substitute in carefully and then simplify it carefully. So negative 4y squared plus 4, negative 4y, then multiply with y. Then 3y squared is 3y squared lah. Okay, nothing to substitute. Equals to 5. Okay, so if I try to simplify all this, right, I should have 48y squared minus 16y squared plus 3y squared equals to 5. 35y squared equals to 5. Therefore, my y value is 1 over 7. Y squared is 1 over 7. So to take the y, I need to consider the plus minus sign for 1 over square root 7. Okay? So if I have y equals to plus minus 1 over square root 7, right? So you can substitute back into the equation number 1 to get the value of x. Okay, so when y equals to positive 1 over square root 7, what's the value of x? So the value of x is equals to negative 4 over square root 7. Okay, so the other way around, if let's say my y is equals to negative, then what's the value of x for this case? My value of x will become positive 4 divided by square root 7. Okay, so this is actually the coordinate for the points that fulfill the criteria where the gradient of tangent at these 2 points is equals to negative 2. So you need to write it out in the coordinate form where I'm having first point is negative 4 over square root 7, y coordinate is 1 over square root 7. Okay, and then the second point is 4 over square root 7, then y is negative 1 over square root 7. Right, so this is how we get the answer for the coordinate. And please take note again, the answer must be in exact value like this, exact coordinate. Alright, you shouldn't change it, become the decimal number. Okay, so this is how we solve question number 7. Okay, so we come to question number 8. Alright, so we are having the variable x and y. Satisfy the differential equation of this, and then it is given that y equals to 0 when x equals to 1. They want us to solve the differential equation, obtaining an expression for y in terms of x. Okay, so this is a differential equation question. Before we can solve the differential equation, we need to separate the variable y and x first. Okay, so this is what I have for my differential equation. So to separate them, I will want to group all the x at right hand side, all the y on the left. So which means that if I try to rephrase my fraction here, right, my equation here, I'm having 1 over 9x squared plus 4 dy. Then equals to, for this ex, I keep it on the left. So I'm having negative 2x plus 1 e power negative 2x plus 1, then dx. Okay, so you can see very clearly that we already separate. Oh, so I think I write a mistake here, right? There's a error here. It should be 9y squared, not 9x squared. Okay, so after I separate, you can see we separate the variable clearly, all the y on the left, all the x on the right. Then we can start the integration. Okay, so before we want to start the integration, what is the formula that we can use? Or how can we integrate 1 over 9y squared plus 4? So we can try to refer to the formula booklet that we have about the integration part. So for this one, you can have a look here. When we are having 1 over x squared plus a squared, then the formula that after integration that we get, the equation that we get after integration, it will be 1 over a tangent inverse x over a. But to apply this particular formula here, you need to ensure that the coefficient of x squared is a 1. Okay, when the coefficient of x squared is a 1, then only you can apply this formula directly. Okay, so please take note on this. So let's go back to the solution here. We are not having the y squared coefficient which is equals to 1, right? If I want to make the coefficient of y squared equals to 1, I will need to factorize out the 9. And I'm having 1 over y squared. Then 4 over 4, or 4 becomes 4 over 9. So when I have 4 over 9, if I want to express it, become something with square, right? It will be 2 over 3 squared. If you have 2 over 3 squared, after you expand it, you are having 4 over 9, which is the original term that we have here. All right. Okay, so I try to rephrase my equation into the pattern of 1 over x squared plus a squared. So you can see this pattern clearly now. And then I keep it as dy here. Then for the left hand side, there's nothing that we can do. We can directly integrate it. So integrate e power negative something. I will have e power the negative something, copy back. After that, I need to divide it by the differentiation of the power. So differentiate negative 2x minus 1, right? I'm having negative 2. So I have to divide it by negative 4 on the right hand side, then plus c. Okay, then let's continue to this integration part on the left. Since I already have the pattern, the standard pattern of 1 over x squared plus a squared, so after I integrate, I'm having 1 over a, which is 1 over 2 over 3. A is 2 over 3, right? So 1 over 2 over 3, 1 over a. Then tangent inverse x over a. So here, of course, I cannot use the x. I should use the y, right? Then divided by a, 2 over 3. So this is what we have after the integration. And then I'm having negative 1 over 2 e power negative 2x minus 1, then plus c. Okay, then maybe I want to further simplify all the fraction here. If I try to simplify all the fraction here, I will get 1 over 6. Then tangent inverse 3y over 2 equals to negative 1 over 2 e negative 2x minus 1, then plus c. Okay, I want to find out the value for c, the constant c. So I will use the information provided in the question. So they told us that when x equals to 0, x equals to 1, then y equals to 0. That means you try to substitute the value in. So 1 over 6 tangent inverse y equals to 0, I'm having a 0 here, equals to negative 1 over 2, then e power negative 2 times minus 1, you're having negative 3. Then plus c. Okay, so this part on the left is a 0. Okay, then this part, if I bring it over, I'm having c equals to 1 over 2 e power 3. Okay, because e power negative 3, you can rewrite it become a denominator with e power 3, right? Okay, so my c become 1 over 2 e power 3. Okay, therefore, I will get my equation, my solution, particular solution, with the value of c 1 over 2 e power negative 3, e power 3, sorry. So if I rewrite my equation again, I'm having 1 over 6 tangent inverse 3y over 2 equals to this 1 over 2 e 2x plus 1, then plus 1 over 2 e power 3. Okay, and now we try to rephrase our equation become y in terms of y in terms of x. Okay, so now I want to slowly move all the 6 and everything over. So now I try to move the 6 over, become multiply 6. Therefore, I'm having tangent inverse 3y over 2. Multiply 6 on the left hand side. For both terms, I'm having negative 3 over e power 2x plus 1. Then plus 3 over e, then power 3. Okay, then what else can I do here? Alright, so next step, I want to bring the tangent inverse over. So tangent inverse over become tangent. Okay, so I'm having tangent. Maybe for me, I will want to put the positive in front. So I put the 3 over e power 3 in front. It will become 3e power negative 3. Then minus 3e negative 2x plus 1. Okay, then again, move the 2 over. Okay, then again, last step, try to move the 3 over. So eventually, the equation that we get, y in terms of x will be this one. Of course, this particular term here, you want to keep it as a fraction also can. You want to keep it as a minimum negative power also can. Alright, so for me, I keep it in this way, which is a negative power. Okay, so some students will want to put it in a fraction form also, no problem, right? So this is my particular solution for the differential equation, where we already try to rephrase the equation become y equals to something something x, y in terms of x. Alright, so this is part A. Now let's proceed to part number B. For part number B, they are saying that what happened now when the value of x tends to infinity? Okay, and then give your answer in exact form. So I rewrite my answer again just now. My answer just now is having something like this. Y equals to 2 over 3, and then tangent 3e power negative 3 minus 3e negative 2x plus 1. Okay, and then now they are telling us that, okay, my x is going to be a very large value, which is infinity. So what happened to the value of y? So for this kind of question, you need to substitute infinity into your equation so that you can see what do you have. If I substitute x here, so I'm having e power negative infinity. When I'm having e power negative infinity, right, you can try to use a calculator to help you to press. If let's say you have no idea how to find an answer, you can maybe press e power negative 1000 or what 10,000 and see what's the value that you will get from calculator. By right, you should get a very small value, because from the graph, right, if I'm having e negative infinity, okay, maybe I draw the e positive infinity first. This is a graph for e positive infinity. E power x. I shouldn't say e power infinity, e power x. Okay, you pass through the 1. Okay, so you can see that when x is going to be, sorry, wait for a while. So, yeah, so now I want to substitute the x become negative infinity, right? So here x is going to be negative infinity. So you can see that our graph getting very, very close to the x-axis, where the small value of y will be very, very small. So when the value of y will be very, very small, that means that this whole thing will be equals to 0. Or maybe it tends to be 0 because the value is super small. Okay, so we can assume that it is a very, very small value. Therefore, we assume this value is close to 0. So if e power negative infinity close to 0, right? So this whole part at the back becomes 0, correct or not? So we only have something in front where the y will be actually equals to 2 over 3, then tangent 3 e power negative 3. Okay, so this is actually our answer. All right. Okay, so to get this answer, you need to have the idea, right? What is the value that we will get when we substitute negative infinity into the e power x? All right. So basically, you can see from the diagram here, it should be equals to 0. It's a very small value. Therefore, we assume that it is equals to 0. And then when we simplify our expression here, we'll get this as the final answer for y when x tends to be infinity. Okay, so this is how we solve question number 9. Question number 8. Okay, so now we are at question number 9. We are given a rational function like this. They want us to express fx in partial fractions. Okay, so first of all, we need to identify what is the degree. Is it what is the pattern, or maybe what is the type of the fraction here? Is this a proper fraction or improper fraction? So you have a look for the the degree or numerator. The highest power for the x is 2, right? So the degree is equals to 2. And then for this one, when you're having x squared multiply with x, you will get the highest degree x power 3. So the degree of the denominator is a 3. When you're having the degree on top is less than the degree at the bottom, that means this is a proper fraction. When you're having a proper fraction, you can straight away or directly expand it into the partial fraction. Okay, right. So after we already know that it is a proper fraction, then let us start. To separate them into the partial fraction, we need to have a look at what kind of function do we have in the denominator. So in the denominator, we are having this one, which is a linear factor. And then this one is actually a repeated linear factor because of the square outside. Right, so we're having a repeated linear factor. For the repeated linear factor, right, you have to write out the partial fraction twice. First time is without the square, the second time is with the square. So if I try to rewrite the pattern of the partial fraction, it will be looking something like this. Okay, I'm having 1 plus 2x, 2 minus x squared, then equals to, first linear factor is 1 plus 2x. So I just put it as 1 plus 2x as the first fraction, first partial fraction. Then the second partial fraction will be b, the linear factor without the square. So it will be 2 minus x. And the third time will be the repeated factor, where when I put the 2 minus x, I should include the square. Right, so this is a pattern for us for the partial fraction. Now I want to find out the a, b, and c. To find the value for a, b, and c, I multiply the whole equation with the denominator. The original denominator, which is 1 plus 2x, then 2 minus x, and then square. Okay? Right, so if I multiply the whole equation with the original denominator, left-hand side, I have a very nice fraction, very nice expression here, equals to, for the right-hand side also the same, 1 plus 2x, simplify with 1 plus 2x, so a multiply with 2 minus x squared. Then for the b, you simplify 2 minus x is 1 of the 2 minus x, therefore I'm having 1 plus 2x, then left 1 more 2 minus x. Then for the c here, 2 minus x squared, simplify 2 minus x squared, so you're having c, and then 1 plus 2x. Okay, then now we will continue to find the value for a, b, and c. There are many ways for you to find the value for a, b, and c. You can compare them after you expand, or maybe you can eliminate the unwanted unknown. So to eliminate the unwanted unknown, first of all, we'll focus on one of the factor. So let's say I focus on this factor, 2 minus x. How can I make this bracket become 0? If I want to make this bracket become 0, I will let x equals to 2. That means if I substitute x equals to 2 here, this bracket becomes 0, this bracket also becomes 0, then very easily I can find out the value for c. Okay, substitute 2 into the whole equation here. Okay, so 2 times 4 plus 17 times 2 minus 17. By using calculator to help you, you might get the answer, which is 25, if you didn't do any careless mistake. 2 substitute into this bracket becomes 0. 0 times a is a 0. 0 times anything with b also equals to 0. Then for this one, I'm having 1 plus 0c. So it will be c. 1 plus 0 plus. 2 times 2 is a 4, right? 4 plus 1 is a 5. Therefore, I will have 5c here. Okay, then if I continue to simplify it, of course, I can kind of get a value for c. C is equals to 5. Okay, so this is how I get the value for c. By focus or referring to the bracket of 2 minus x. Okay, then now, after I use the first factor here, 2 minus x, now I'm looking for the second linear factor. Is there any other second linear factor that I can use? So now I look at this 1 plus 2x and also 1 plus 2x. These two are also the linear factor, right? Okay, how can I make this bracket become 0? I need to let x equals to negative 1 over 2. Okay, if I let x equals to negative 1 over 2, substitute into the whole equation again. Okay, so use calculator to help you. The left hand side, if you substitute negative half into the whole expression on the right, you have negative 25. Substitute negative half into this particular part, you are having 25 over 4a. Substitute negative 1 over 2 into this bracket, you'll get a 0. 0 times anything becomes 0 as well. Same thing happened for the last term here. Negative half. Substitute inside this bracket, multiply with 2 plus 1, you get a 0. So 0 times c also get a 0 here. And again, now your solution here we will actually get the value of a very easily, which is negative 4. Okay, so we already get the value for both a and c, right? And now, which is the third factor that I can use to find the b? Okay, so if you try to observe it again, you realize that basically we have used all the possible linear factor that we can use. There's no more linear factor available for us to make it become 0 anymore. Because if you double check all the bracket here, we have been used. It has been used. Okay, for us to make it become 0, to get the value for a and c. So now, for the last value of b, you can substitute x equals to any value that you never used before. So for me, I will always use a 0. If let's say 0 is never been used before, then I will use x equals to 0. Substitute x equals to 0 into the whole equation here. I'm having negative 17 equals to, substitute x equals to 0. You're having 2 squared. 2 squared is a 4. 4 times a. A is negative 4, right? And therefore, you're having negative 16. Okay, when x equals to 0, 1 times 2, you get a 2, so you're having 2b. When x equals to 0, 1 times c, and c is a 5. Okay, so from here, you also get the equation in terms of b, and from there, I think you're able to solve for the value of b. If you didn't do any careless mistake, the value of b should be equals to negative 3. Okay, then now once you get the value for A, B, and C, that means we already actually get the partial fraction. Usually for my practice, I'll prefer to write out the expression again. So 2x squared plus 17x minus 17 divided by 1 plus 2x and then 2 minus x squared can be equals to this partial fraction. 1 plus 2x, then 2 minus x, and the third one will be 2 minus x squared. Alright, so basically this is what we have for the partial fraction. Okay, alright, then we can proceed to the next part. Part number B. Okay, for part number B, hence they want us to show that the integration of fx equals to this particular value. Okay, to apply for the integration, right, instead of using the original rational function, we should use the partial fraction that we already get just now in part 1. Therefore, they use the word hence, right? Okay, so straight away, integrate the value here. I'm having negative 4 over 1 plus 2x. Then minus 3 divided by 2 minus x, and then plus 5 divided by 2 minus x squared. Okay, before I apply any integration, I will want to make it become a pattern that is easy for me to integrate. Okay, so for first term, nothing special. So I will just keep it as original like this. Then for the second term, I don't like to have a negative here. I will want to multiply it inside the bracket here. So when I multiply inside the bracket here, then I will have a plus 3 over x minus 2. Okay, after that, for this third term, I will need to rephrase it become 2 minus x the whole square, power negative 2, sorry. When I bring it out from the denominator, the power will become negative, so I'm having negative 2. Okay, so next step, I'm going to start the integration. Integrate this thing, it is negative 4 is a constant, I just copy. Integrate 1 over 1 plus 2x, you have ln, and then 1 plus 2x. You need to differentiate the thing inside the ln. So differentiate the 1 plus 2x inside the ln, you get a 2, right? So you have to divide it by a 2. So this is the integration for the first term. After that, integrate value for the second term, the expression for the second term. 3 is a constant, therefore I just copy. And then integrate 1 over x minus 2. I will have ln x minus 2. Then divided by differentiation of the bracket. Differentiate x minus 2, you get a 1. Therefore, you divide it by 1. Okay, then plus, for this one, 5 is a constant, you just copy. When you're having a bracket with power negative 2, you apply the AS concept in integration, where you copy the bracket power plus 1, which is become negative 1. So you have to divide it by the new power, negative 1. After that, you have to differentiate the thing inside the bracket. So differentiate 2 minus x, you get negative 1 as well, right? So you also need to divide another negative 1 here. Then only you can substitute in the limit 0, 1. Okay, so before I want to substitute in the value, the limit into my equation, I will prefer to simplify my answer first. So negative 4 divided by 2 have negative 2. To me, if you simplify it earlier, right, it will be easier for us to avoid careless mistake later. Okay, so negative 1 times negative 1 is a positive 1. I'm having plus 5. Then 2 minus x. Then 1 and 0. Okay, so now everything looks good. Substitute the first limit 1 into the whole equation here. I'm having negative 2 ln 3, right? 1 times 2 plus 1 is ln 3. Then plus 3 ln 1 minus 2 is a negative 1. Basically, we have to change it become positive because ln negative value is undefined. So I will change it become a 1 here. So 3 ln 1. Then plus 5 divided by 1, which is a 5. So I write as 5. Then minus, now I want to substitute 0 into the whole equation. I'm having negative 2 ln 1, then plus 3 ln negative 2. So I change it become ln 2, then plus 5 over 2. Okay, then so slowly simplify them. Okay, please take note that ln 1 is equals to 0. So all this will be equals to 0 here. Then if you try to observe the final answer provided in the question, right, you can see that ln 72, in front of the ln there's no number, right? It is not something like a 3 ln 72 or 3 ln 2, something like that. So to make sure that there's no number in front of the ln, I will want to move my number in front, go backward, so that it become a power. Therefore, for this question, I'm having ln 3 power negative 2. Okay, 3 ln 1 is a 0, then plus 5. 2 ln 1 is a 0 as well. Then again, I have minus. Now, the 3, I bring it over, going back. So I'm having 2 power 3. Okay, then minus 5 over 2. You can simplify all the power together. All the constant, the pure number together, 5 minus 5 over 2. Therefore, you are having 5 over 2. Okay, so for this one, ln 3 power negative 2, you are having ln 3 power negative 2 means 1 over 3 power 2, right? So you're having 1 over 9. Then minus ln 2 power 3, that means ln 8. Okay, so we are very, very close to our final answer already. If you have a look for this one, then basically you can see that I have 5 over 2, which is the correct answer already. Then for this part, we need to further simplify it. So how to simplify further? Okay, ln 1 over 9, I can write become ln 1 minus ln 9. When you separate them, right? So minus ln 8. Okay, so again, ln 1 is a 0. So I will want to factorize out the negative. Therefore, I'm having ln 9 plus ln 8. Okay, then 5 over 2, then minus 9 times 8. Ln 9 plus ln 8, you can combine them together, become 9 times 8. So 9 times 8, I got 72. So this is how I get the answer that they want us to show. Okay, so of course for to simplify your answer after the integration until this step, right, there are many different ways that you can interpret the question, express the solution, rephrase the solution to get the answer. Okay, so what I show you here is just a suggestion. All right, so your step might be different from mine, but you can apply any concept that you feel is correct or property that you feel is correct to get this value. All right, okay, so this is how we answer question number 9. Okay, so question number 10. We are given a diagram and then it shows the curve and maximum point is the M. Okay, they want us to find the exact coordinate of the curve, so highlight the keyword exact. Right, so exact means that your final answer later for the coordinate of M must be in either surd form or maybe pi form. All right, it cannot be a very long decimal number. Okay, so to find the maximum point, M is the maximum point, right? To find the maximum point, you need to find out dy dx first. After that, you let it equals to 0 and you try to solve that. Okay, so how to find the differentiation for the equation of y here? If you can observe clearly, then basically this is a product of two function, right? So when you're having a product of two function in the equation y, when you want to find the dy dx, you have to apply product rule for differentiation. Okay, so for the product rule of differentiation, the idea is copy the first bracket, differentiate the second, and then copy the second bracket, differentiate the first. Alright, so we will start. I'm having two brackets here very clearly. So I want to find out dy dx. So to find the dy dx, what I can do is I copy the first bracket first, copy the first, differentiate the second. To differentiate this bracket, the power half I have to take it in front, copy the bracket, power minus 1, which is negative half. Then you have to differentiate the thing inside this bracket again. Differentiate 3 minus 2x, you get negative 2, right? So you're having negative 2. Okay, so you are done for the first part. Now you want to do it the other way around, where you copy the second bracket, then you differentiate the first bracket. Differentiate x plus 5. What do you get? You'll get a 1, right? Okay, then this is what we have after the differentiation. So to find out the x coordinate or maybe the y coordinate for point M, you will need to let dy dx equals to 0. Okay, so if I let dy dx equals to 0 and I try to simplify all the terms here, the 2 and negative 2 can be cancelled off. So I'm having negative x plus 5 divided by square root of 3 minus 2x. Okay, therefore this one, you are having the square root of 3 minus 2x. Okay, if I rephrase my equation here, bring this particular term over, become positive, it is equals to square root 3 minus 2x. Okay, bring the square root over, I'm having 3 minus 2x. Therefore, from here, we can solve the value of x very easily, where it should be negative 2 over 3. Okay, so after you get the x value, the x coordinate, you have to continue to find the y coordinate, right? They are asking for exact coordinates. That means both x and y are needed. Okay, so to find the y coordinate, I need to substitute the x into the y equation. Okay, so I substitute the x into the y equation, then I will have negative 2 over 3 plus 5. Then with a square root of 3 minus 2, negative 2 over 3. Okay, then I need to simplify this one slowly. For the first bracket, I'm having 13 over 3. For the second bracket here, I'm having 13 over 3 power half or square root. Okay, all right. So from here, after this step, right, there are a few ways that you can write your equation of y. So some students, they will write straight away become 13 square root 13 divided by 3 square root 3. Okay, or some of you might want to rationalize it, right? Because you might not like to see the square root 3 at the bottom. If you rationalize it, so your denominator will have a 9. Then on top, you're having 13 square root 39. Because you take square root 13 multiplied with square root 3, so you're having square root 39. This is another way of writing it out. Okay? Or some might tend to write it out in the power form, where you're having 13 over 3. Because this one, if you have a look here, this whole thing here is a 1, power 1. So when you're having 13 over 3 power 1, multiply with 13 over 3 power 1 over 2, your answer should be 13 over 3 and then 3 power 3 over 2. Okay, so there are many ways for you to write the coordinate for y, but just make sure that when you write it out, it should be in the third form, okay, or exact form. That means you shouldn't have any long number or long value, okay, long decimal number. Okay, so once you get the m already, the x and y coordinate, maybe you can write it again in a complete coordinate geometry form. So the x coordinate will be negative 2 over 3, and then for the y coordinate, you can write as 13 square root 13 divided by 3 square root divided by 3 square root 3. So 13 square root 13 divided by 3 square root 3. Alright, so this is how we actually find out the exact coordinate for the m. Alright, then this is how we solve part A of question number 10. Okay, so let's continue to part B. For part B of question number 10, they want us to use the substitution. They already give us the keyword about the integration technique, which is substitution. U equals to 3 minus 2x. Find by integration the area of the shaded region bounded by the curve and the x-axis. Give your answer in this pattern a square root 13, where a is a rational number. Okay, so to find out the area of the shaded region, basically we need to apply integration. Okay, so maybe we need to have a look one more time. What do we have here? So this is a shaded area. To find out the shaded area, I need to know what is the limit of the integration. So I need to know what is the x coordinate, x-intercept for these 2 points here. Okay, so I need to find out these two value here first. After that, only I can start the integration. Okay, so to find out the value of x-intercept, I need to let y equals to 0, right? Okay, so my original equation again, y equals to this one. Okay, then I let y equals to 0. And I want to get the value of x. So from here, I get two value of x, which is x equals to negative 5. Another one will be x equals to 3 over 2. This 2 value will be actually our limit for the integration to get a shaded area, because our area start from -5 until 3 over 2. Okay, so to get the shaded area, okay, the general formula will be integration from -5 until 3 over 2 for the equation of y, which is x plus 5, and then 3 minus 2x power half dx. Okay, then again, because this is not an equation that we can integrate them directly because it looks a little bit complicated. So they already suggest us a method to integrate it, which is a substitution. All right. So now to continue with the substitution integration, I will write my solution here. Okay, I will start from u equals to 3 minus 2x first. Okay, my solution, everything is in terms of x. So to use a substitution method, right, I have to change all the things here become u. Okay, so if I try to rephrase my equation again, my 2x equals to 3 minus u, and therefore my x equals to 3 minus u over 2. Okay, so this is one of the substitution that I can apply it later. Okay, so besides this, I also want to continue from here with differentiation. If I differentiate this equation, du dx, I will get -2. Okay, therefore, if I want to know what is my dx equals to, dx will be equals to -1 over 2 du. Right? Okay, so I have the x in terms of u, I have dx in terms of du, and now we will want to change the limit. All the limit here, -5 and 3 over 2 are belongs to x. So if I want to know what is the value of u after I substitute the value x, okay, so when x equals to -5, when x equals to -5, so what do you get for the u? Okay, substitute -5 here, your u will be equals to 13. Okay, after that, when x equals to 3 over 2, what is the value of u? So you realize that if you substitute 3 over 2, your u will be equals to 0. Okay, if now we have get everything ready, that means we have tried to rephrase everything become x in terms of u. Okay, and I can now starting to put in all the value here. Okay, so you can see when x equals to -5, x equals to -5, I get a 13, right? So we should follow the original location of the limit. So if -5 is at the bottom, so I just put 13 here. 3 over 2, when x equals to 3 over 2, I get u equals to 0, right? So the 0, I put it on the top. Okay, so although after you change the limit, you can see that, oh, the bigger value is at the bottom, right? But actually it is fine. We need to follow the original location of your original limit. Okay, so you'll keep the 13 at the bottom, 0 on top. Okay, so what is the value for x plus 5? So to get the value for x plus 5, you substitute the x with 3 minus u over 2. Because x equals to 3 minus u over 2, right? Then you put a plus 5 here. Then what happened to 3 minus 2x power half? 3 minus 2x, you know that it is a u. Therefore, you can write it out become u power half. Then what is dx here? So just on dx, you know that it is equals to -half du. So I'll multiply with -half du at the back. Okay, so now you can see very clearly that I try to change everything related to x everything become u. Okay, then again, before I can integrate it, I still need to rephrase it one more time. Okay, for the first bracket here, after I rephrase, I will get the number 13 over 2. You take 3 over 2 plus 5, so you get 13 over 2, then minus half u. Then multiply with u power half, then multiply with -half, and then du. Okay, then from here, right, I can see very clearly also that -half is a constant. So to make my steps looks not so complicated, I prefer to factorize them out. Same thing happened for this half inside the bracket. So if I factorize out the -half, I factorize out the half, I'm having -1 over 4 in front. Okay, then in the bracket, I have 13, right? After factorize out the half, I have 13. So for this particular 13, I need to multiply with u power half. So I'm having 13 u power half. Then for this particular term, after I factorize out the half, right, I left the u. So u multiply with u power half, I'm having u power 3 over 2. Then du. Okay, so after you rephrase it nicely, right, you can see very clearly, oh, my equation become much more easier to integrate. Okay, so now you can start the integration. 13, just copy 13 is a constant. U power plus 1 become 3 over 2 divided by the new power. Then minus u also you copy, power plus 1 become 5 over 2 and you divide it by the new power 5 over 2. And you want to substitute the limit 0 and 13 later. Alright, then again, for my practice again, before I integrate or substitute any value, I will want to simplify my fraction or my expression first so that it doesn't look so complicated to avoid careless mistake. Okay, so 13 divided by 3 over 2. Okay, so what do you have? So 13 times 2, you're having 26. So you're having 26 over 3 with u power 3 over 2. Then for this particular term, you're having 2 over 5 and then u power 5 over 2. Okay, then next one. Now you can start to substitute in the value lah. Okay, so first of all, you substitute the value 0 into your expression here. So when you substitute 0 into your expression, this whole expression is a 0, so I didn't write it a lot, so I just simplify as a 0. Then before you want to substitute, the power 13 is minus, right? Okay, so substitute power 13. 13 into the equation here. You have 26 over 3. Okay, then 13 power 3 over 2. So now here I want to mention about 13 power 3 over 2 before I simplify them in my step. Okay, so I'm having 13 power 3 over 2, right? How can I simplify 13 power 3 over 2? Maybe I can show you later. Okay, then minus 2 over 5, then 13 power 5 over 2. 13 power 5 over 2. Okay, all right, so for those who are using ES calculator, right, you might not have a problem of simplifying this 13 power 3 over 2 and 13 power 5 over 2 because your calculator might help you nicely to simplify it already. Okay, so let's have a look. If let's say I'm having 13 power 3 over 2, what do I get? Oh, I also didn't get a nice value, right? Okay, so maybe now we need to learn how to simplify it nicely. 13 power 3 over 2 can be written as 13 power 1 multiply with 13 power half, right? So that when you have a power m multiply with a power n, the power is m plus n. So if you take 1 plus half, it is equals to 3 over 2. So we are doing it backward. Okay, so if I want to simplify 13 power 3 over 2, then I will have 13 power 1 multiply with 13 square. 13 power half. Why do I need to separate it in this way? It is because of, if you observe back to the question, right? The part B question. They say now I want to have my answer in terms of a square root 13. So I have to ensure that I need to simplify my 13 into the most simplified version, which is square root 13 here. Okay, so 13 power 3 over 2 is not the most simplified version yet. I want to have 13 power half, which is this one. Okay, therefore after I simplify this, I will multiply inside. Okay, so the negative and negative cancel off. I'm having 1 over 4. Okay, so 26 over 3. Then 13 multiply with 13 power 3 over 2, I'll get this one. So when I write out, I'm having 13. Then 13 power half, I can write as square root 13. Easier for us to do the calculation later. Alright, so I'm having 13 here. Okay, then minus 2 over 5. Now I need to simplify this 13 power 5 over 2. How can I simplify this 13 power 5 over 2? So you can write become 13. 5 over 2 is 2 plus half. I want to have the half in my calculation, right? So when you separate them, it will become 13 multiplied with 13 power half. 13 square multiplied with 13 power half. So again, this is square root 13, right? So in my solution here, I'm having 13 square then multiply with square root 13. Okay, then after that, 1 over 4, try to multiply up all the number together. So you're having 338 over 3 square root 13 minus 13 square multiplied with 2 over 5. You're having 338 over 5. So 338 over 5 square root 13. Now you can treat the square root 13 as apple lah. So you're having 335 over 3 apple minus 338 over 5 apple. So 338 divided by 3 minus 338 divided by 5. What do I get? I get a fraction also, which is 676 divided by 15. Then square root 3. Oh, sorry, not square root 3, it should be square root 13. Alright, then after that, again, multiply the 4 with the value. Multiply 1 over 4, the fraction 1 over 4 with the value 767 over 15. Then you get 169 over 15 square root 13. Okay, so maybe the way of simplifying this value might be slightly longer. Okay, but I'm trying to show you all the details so that you understand how we rephrase it. Of course, some students might be able to use the calculator straight away to solve to rephrase it also can, no problem. Alright, so I'm showing this to those who are using MS calculator that not able to show you nice number in the third form. Alright, so basically this is how you need to rephrase your equation to get the final value that they want. Alright, so the answer for this final value is 169 over 15 multiplied with square root 13. So A is 169 over 15. Alright, so this is how we solve question number. Okay, so now we are at the very last question for this paper. Okay, we are having points A and B with the position vector given like this. And then we are having the line L with the vector equation of this. Okay, they want us to show that L does not intersect the line passing through A and B. So first of all, we might need to find out the line passing through A and B first. Okay, to form the vector equation of A and B that pass through the A and B, the direction of the line basically is the direction AB lah. Okay, you can use also the direction BA, also no problem, they are the same actually. Just that in the opposite direction only, right? But they are still at the same slope lah, or maybe the same gradient. Okay, so to find the A and B, it is AO plus OB. Okay, so what is AO that I have here? AO will be equals to -1 minus 2, then 2. OB is 2, -1, and 1. Okay, so if I simplify them, then I'm having I'm having 1, sorry. I'm having 1 here, then -3 and also 3. This is the direction for the equation of line AB. Okay, so after I get the direction, I can form the equation vector equation of AB. Okay, so to form the vector equation of ABB, right, we are having R equals to the A is the passing point. You can use any passing point of the line AB lah. So in our case here, you can use the point A or you can use the point B also, no problem. Alright, so if point A is 1, 2, -2. Okay, plus TP. T is a variable with some value here, and then the P will be the direction of the line. Direction of the line, we already get it just now, which is 1, -3, and 3. Okay, so first I get the vector equation for AB, and now they actually want us to prove that the line L and the line AB does not intersect. So to prove that they are not intersect with each other, right, the best way is to equate these two equations, and we try to solve for the value of T and also the value of mu. If let's say they are intersect with each other, right, all the value of T and mu, right, is true for all the equation in the vector equation. For all the component in the vector equation, that means in the component x, y, and z, if you substitute the value of t that you found just now, it should be true. And also the mu, it should be true. Okay, but if let's say they are not intersect with each other, right? Okay, then that means the value of mu and t, after you substitute them into the vector equation, somehow there are some point they are not the same. Okay, so let us start to show now. Okay, what is the equation, vector equation for the line L? So the equation for the line L will be equals to, I combine them and become 1 plus 2 mu. Okay, then negative 1 minus 3 mu, and also 3 plus 4 mu. This is the vector equation of the L. Then I let it equals to the vector equation for AB. So for this vector equation of AB, I'm having 1 plus t, 2 minus 3t, then negative 2 plus 3t. Okay, so first of all, of course, I want to find the value for t and also the mu. Okay, to find the value for t and also the mu, right, there are three equations here. The first one is the component x, second one is the component y, the third one is component z. So there are three equations here in terms of mu and also the t. You need only two to solve and get the value for mu and t, right? So maybe I will use the first one and also I will use the second one to solve for the value of mu and t. Okay, so from the first equation here, I'm having 1 plus 2 mu equals to 1 plus t. Therefore, the t here equals to 2 mu. And this is my first equation that I get. Then for the second equation, I'm having negative 1 minus 3 mu equals to 2 minus 3t, right? Okay, so I'm having 3t equals to 3 plus 3 mu. And after that, my t is equals to 1 plus mu. So I actually have two equations in terms of t and mu. Therefore, if I try to solve them, I'll get the value of mu first. So 2 mu equals to 1 plus mu. And eventually my mu is equals to 1. If my mu is equals to 1, substitute back into the equation number 1 or equation number 2, then you can get the value of t, which is equals to 2. Okay, so I already get the value for mu and t, right? If the both lines are intersecting with each other, that means if I substitute these two values into the third equation here, these two values will be the same. If after I substitute these two values into the equation and I didn't get the same answer from left and right hand side, that means the value of mu and t are not true, are not correct for the third component in this vector equation. Alright, therefore, that also means that they are not intersecting with each other. So that's the meaning. Okay, so now we will proceed to the next part where we want to check. Okay, if I want to check, I will start from left hand side. So the left hand side is 3 plus 4 mu. So 3 plus 4 mu, what do I have? I'm having 3 plus 4, which is equals to 7. And then for the right hand side, I'm having the equation, this one, negative 2 plus 3t. Negative 2 plus 3t. Okay, so equals to negative 2 plus 3 times 2, which is a 6. Okay, and I'm having a 4. So I think it is very clear to show that left-hand side value is not equals to the right-hand side value, right? Okay, which means that the value of mu and t are not consistent for all the three components. Therefore, the line AB and the line L are not intersect with each other. Okay, so this is how we prove it. In fact, these two lines are actually skewed. All right, they didn't touch each other. Okay, at any single point. All right, then now let's proceed to part number B. Okay, so for part B, now they want us to find the position vector of the foot of perpendicular from A to L. So if you try to observe, let's say this is a line L. I simply draw a line L, and then let's say this is the point A. What is the foot of perpendicular? So that means if I draw a straight line from A to L, right? The intersection point between the line A and the L for 90 degree. So this is foot of perpendicular. For me, I will label it as F. Okay? Alright, and now they want us to find out the coordinate or maybe the position factor for this point. Okay, for this particular point here, the foot of perpendicular. Okay, so first of all, we need to know what is the position vector of OF first. Okay, so to get the position vector of OF, because it is lying on the line L, F is lying on the line L, right? So the position vector for F is actually the equation of line L as well. Okay, so what's the equation for line L just now? Vector equation. I'm having 1 plus 2 mu. Okay, so negative 1 minus 3 mu. okay, and also 3 plus 4 mu. If you don't want to confuse yourself, you can replace the mu by using maybe s or maybe some other value lah. Sorry, some other letter. Okay, but no matter how, basically, because f lies on the line L, therefore the vector equation of OF, position vector of OF will be equals to the vector equation of L. Okay, so this is what I have for OF. Okay, then now I need to think a way to find the mu here lah, so that I know what is the position vector of the OF one, right? Okay, so to find the mu, very likely I need to form another equation to solve for the mu. Okay, so what can I do now is, I know that A and F are perpendicular with the line L, right? So maybe I try to find out AF first. What is the vector AF? For the vector AF, it is AO plus OF. Okay, so what is AO? Again, refer to the position vector at A. From the previous part, I'm having -1, -2, and 2. And then OF is what we write out just now, right? Which is 1 plus 2 mu, -1 minus 3 mu, and then 3 plus 4 mu. Okay, then I try to simplify it. -1 plus 1, I get a 0. So I'm having a 3 mu here. Okay, -2. With this, I'm having -3 minus 3 mu. And then the bottom one, I'm having 5 plus 4 mu. So this is a vector AF. Alright, so vector AF also have mu, right? So what is the useful information that I can use to find out the mu here? Okay, so like what I mentioned just now, because I know that AF is perpendicular with the line L. Therefore, if I take the vector AF dot with the dot product with the direction of the vector equation L, then I will get the 0. Okay, because according to some property that we learned earlier, right, when two lines or maybe two vectors are perpendicular to each other, so you take A dot B, it will be equals to 0. So same thing happen here. So I'm taking the vector AF dot product with this horizontal line. The horizontal line, I have to use the direction. So what's the direction for this horizontal line L? The direction is this one, 2, -3, and also 4. So I need to dot product with the P lah. I will mention it as a P, which is the direction for the line L. Okay, and then from here we know that AF is 3 mu, then -3 minus 3 mu, then 5 plus 4 mu, and dot product with the direction 2, -3, and also 4. Eventually, I'll get it equals to 0 because of they are perpendicular to each other. Okay, then continue from here. So what I need to do now is wait, I think I make a careless mistake, right? Okay, sorry, I think this part I made a careless mistake because when I check the answer, I realized the value are not the same. AF is AO plus OF. Okay, so -1 plus 1 should be 0, so plus 2 mu, which is 2 mu. So there's a error here. This one shouldn't be a 3 mu, it should be a 2 mu here. Okay, right, then of course this part also I need to make it become 2 mu. Okay, then now only I start the dot product between these two vectors. So x multiply with x, so 2 mu multiply with 2, you get a 4 mu. Then after that, plus, you're having -3 multiply with -3, -3 mu. Then plus, you're having 4 multiply with the 5 plus 4 mu. That means x multiply with x, y multiply with y, and also z multiply with z. Okay, so after I get this one, I try to rephrase them and simplify them. So 4 mu plus 9 plus 9 mu. Then 20, 16 equals to 0. Okay, if you try to simplify everything slowly, you have 29 mu equals to -29. And then you get the value of mu, which is -1. Okay, so once you get the value of mu here, then you can substitute it back into the vector, the position vector of the OF. Then you can get the position vector of F already. Alright, so substitute the mu equals to -1 here. Okay, substitute it here, substitute it here. Okay, then you'll get the answer for OF. So for OF, you will substitute it. Substitute negative 1 into the x component, you're having negative 1. So if I write, you can write it as negative I. Okay, then substitute negative 1 into the y component, you have a 2. So it will be plus 2j. And after that, substitute the negative 1 into the z component, 4 plus 3 times negative 1. Then you're having a negative 1. So it will be a negative k. Alright, so by right, this is your position vector of the point F, which is perpendicular, the foot of perpendicular between the A and also the line. Alright, so this is how we actually solve this question. Okay, alright, so we have ended the discussion for this paper. Okay, so thank you so much for watching this video.